look at example 3. So this is incredibly useful when you have a radical on both sides of the equation. So you have square root of 3x minus 17. So you got radical on this side, and you have a radical on the other side, square root of x plus 21. Well, this is great, because if I'm squaring this side and I get rid of the square root and I square this side, I get rid of square roots on both sides, and it's very nice because I get left with 3x minus 17 equals x plus 21. And it's then very easy to simplify and just get x. I subtract x, I get 2x on this side, add 17 to the other side, I get 38. Divide both sides by 2, and I get x equals 19. Finally, I'm going to look at example 4. And in this situation, we're going to solve an equation with what's called an extraneous solution. Yet another, just a complicated word. It means there's an extra solution that doesn't work, basically. It's a fancy word to describe. You get more than one solution, and one of them doesn't work. So here we have square root of 6 minus x, and I'm setting it equal to x. Now last time when I squared both sides, I didn't end up with a square, right? I just ended up with an x. But this time when I square both sides, I'm going to end up with x squared on one side. So our quadratic equation equals 6 minus x, right? So you thought you were done with quadratic equations, didn't you? Unfortunately not, because we now have a quadratic equation to solve. So I hope you remember all your factoring skills and completing the square and all those, because we could still use them here. So we're going to set this equal to 0, and 0 equals x squared plus x minus 6, because I've added x to this side and then subtracted 6. Well, we're very fortunate in that this one is particularly easy to factor. Because if you remember, what are the factors that go into -6? I've either got +3 and -2, or the reverse, where I have -3 and +2. Well, since I have a positive x in the middle, I know the positive has to be the bigger number. So +3 minus 2. And when I solve, I end up with two solutions. X equals 2 and x equals -3. Now, in a situation, you have to test solutions, especially if you end up with a quadratic. So here, we're going to have to go back to the original problem, which was square root of 6 minus x equals x, and find out if both of these solutions work. So first, let's try x equals 2. If I have square root of 6 minus 2 equals 2, is that a true statement? Well, that means I get the square root of 4, and yes, the square root of 4 is true. So 2 equals true, yes. Right, so this is a solution. I'm going to circle it. Well, let me try 3 now, or -3. Square root of 6 minus -3 equals -3. Well, square root of 6 minus -3 is the square root of 9, right? 6 plus 3 is 9 equals -3. Well, square root of 9 is 3. And 3 is not equal to -3. Remember, we're only doing the positive square roots. So this is not a solution. -3 is an extraneous solution. Okay, this is an extraneous solution. Okay, So we have looked at solving an equation that has radicals on both sides, and we've solved an equation with an extraneous solution. When I come back tomorrow, we're going to do the word problem, and then we'll be finished.